Okay, so today we're looking at the sine law, and now you can see that we have a triangle that is not a right triangle. So we're going to look at trigonometry using all sorts of triangles and not just right triangles as you have done in previous years. So to develop the sine law, what we're going to do is from B, drop down a height, which I'm going to call h. And now I've separated my triangle into um, two right triangles. And remember how to label this. So if this is angle A, this is side A. If this is angle C, this is side C. And this whole side over here is side B. So what I'm going to do is describe the sine of C. Well, the sine of C would be its opposite over the hypotenuse of this triangle here, A. And so I could say that that height is equal to A times sine C. So I'm just going to hang on to that for a moment, and I'm going to repeat a similar calculation on the other side, looking now at angle A. So the sine of A is its opposite, which is also h, over the hypotenuse of now this triangle, which is C. So that h is also equal to C, I should use lowercase c, sorry, sine A. So if h is equal to this, and h is also equal to A sine C, now I'm going to equate both of them. Equate both expressions for h. So A times sine C equals C times sine A. And now if I divide both sides by A and C, you'll see here that the a's cancel out, and I get sine of C over C equals sine of A over A. And this is part of the sine law. And so if I flip the triangle around and drew in another height, I could add in that also the sine of B over B would be equal to all of these things. And this is the sine law. Okay, there is another format of it, and it's where I flip all these ratios. So, and if I do it in alphabetical order instead, A over the sine of its angle is equal to B over the sine of its angle is equal to C over the sine of its angle. Now, often we're only using part of this and not the whole thing. So let's see this in action and look at some problems. So, okay, this one, I'm going to do above it because I don't have enough room to do it below. I'm just going to clear up some space here to do that. So, I have to draw triangle ABC first. So I'm just going to draw any old triangle. There I have it. And remember that the sides and the angles use the same letter. So angle A is 100. It probably makes sense to put that here. And side A is opposite that is 20. So opposite it is over here. And B doesn't really matter where I put B, so I'm going to say B is up here and C is down there. And B is 16, so this is 16. And I'm going to solve the triangle. To solve the triangle means find all missing sides and angles. And you can see right away, if I have an angle that's 100 degrees, this is not a right triangle. I'm not going to be using standard sine, cos, tan on my calculator like I did in 10th grade. This is going to be a bit different. So what I might start by doing is find out what's angle B. So the sine of angle B over the length of B is going to be equal to the sine of A over A. So now I'm going to fill in what I know. Sine of B I don't know. Over B, which is 16, is sine 100 over 20. And now I'm going to multiply the 16 over here, and I'm going to type that out in my calculator. 16 sine 100, make sure you're in degree mode. Very important. And then divide that by 20, and I get 0.787, blah, 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 blah. So if that's what sine B is, B would be the inverse sine of that value. And I'm going to type in here, or write in here rather, answer, and that's on the calculator where you hit second function and then the little negative sign, and it types in all of this, so I don't have to type it out again. And if I do that, I get 52 degrees. So now I know that B up here is 52 degrees. Well, now I can use the 180 degree rule, minus 100 minus 52, and that's going to give me angle C, which is 28 degrees. So I'm well on my way to solving this triangle. And now I cannot use Pythagoras' theorem to find side C, the missing piece of information. I need to use the sine rule again. Okay, so remember, when it's not a right triangle, I can't use a lot of those things that I learned in the past, except for the 180 degree rule. That's true in any triangle. So C over the sine of its angle equals, say, 20 over sine 100. So C is 20 sine 28 divided by sine 100. And that gives me 9.53. So now I've solved all sides and angles of this triangle using the sine law. All right. I recommend if my variable is an angle, then I put this in the top, the sine of that in the top. If my variable, the thing I'm looking for, is a side, then I use this form of the sine law. All right. Here is one for you to try. So the easiest thing, obviously, is to find angle M, and then use the sine law to find side P and side M. Okay, so maybe pause it here and try and see if you can do that on your own. Okay, so angle M is 180 minus 70 minus 55, and that gives me 55 degrees. So this is actually an isosceles triangle. So that means that M, right away, I know is going to be 10 as well. This angle opens up to that side and is 10. This angle measures the same and opens up here. That must also be 10. So that's a rule in isosceles triangles. Just going to clean this up a bit. There we go. So now I have that. Now I'm missing side, now I'm missing side P. So I would say P over sine 70 equals 10 over sine 55. Multiply sine 70 up here, and P turns out to be 11.5.